Hey everyone, this is our lesson on neutralization reactions, and by the end of this lesson you should be able to infer the quantitative nature of a solution. So we're looking more at the titration molar ratios here that it says. But before you get started, you may want to stop here and review double displacement reactions. So first, let's go over some definitions to know for a neutralization reaction. So when I say neutralization reaction, I'm looking at an acid-base reaction, and an acid-base reaction falls under the category of double displacement. When you see this, you will be mixing an acid and a base together, and that will create salt and water as your two products. So to see this as an example, we have HCl, which is an acid, plus NaOH, which is a base, will yield NaCl, which you can see over here, plus H2O. So just as an example here, and I'll clear off my screen after I do this. So remember with bases, the outers go together and the inners go together. So the inners here will make the salt. So inners will be the salt. Outers will be the water. If it helps you too when you're looking at these, remember water can actually be written as HOH, okay? So if you happen to just put these together and you see HOH, if you want to remember to rewrite it as water, you can. But I do want you to know that is the same thing here if that helps you kind of clarify. We look at neutralization reactions specifically for titrations, which are an experiment to determine the concentration of a given analyte with a titrant. And a titrant is a solution of known concentration that we are adding to something of unknown concentration. So a lot of times we may have the unknown concentration of an acid. Well, we're going to add a base that we do know the concentration of. And once we're going to add it, we'll know once it reacts the way it needs to, how much base we used, and then we can calculate from there. The analyte is something that we do have a known amount for, so we would know the volume that we had, but we wouldn't know the concentration that we have. But it is what's being analyzed, and it's what we're trying to figure out the concentration of. We do this by trying to reach some specific points in a titration. The first one is called an equivalence point, and this is the point when enough titrant has been added to completely neutralize the analyte. So you've got enough for the pH to be 7. And then we've got an endpoint, and this is where the indicator actually changes color. Okay. When we look at a titration, we actually will form a titration curve, which is what you see over here in this GIF. So it literally looks like an S. It's a hill that you form. And to calculate this, or to calculate the values you can get from this, we use what's called a dilution or we use the titration calculation. It looks very similar to our dilution calculation from earlier in this unit. So the formula for dilution was M1V1 equals M2V2. Well, for a neutralization reaction, it is MAVA is equal to MBVB. It's exactly the same, except instead of 1s and 2s, we have A's and B's. And the A's here, of course, stand for acids. The B stands for base. So we're doing molarity of acid times the volume of an acid is equal to the molarity of base times the volume of a base. If the acid or base gives off more than one ionizable portion, so more than one H plus or more than one OH minus, you will have to multiply the concentration by the subscript. So for instance, if you're looking at H2SO4 that has 2 ionizable hydrogens, whatever its concentration is needs to be multiplied by 2 because it's giving off twice as much hydrogen. The more hydrogens that an acid gives off, the more curves on the titration plot it will have, or the more humps the curve will have. So if you look at this picture over here, this is one for H2SO4. So this first curve is for 1 H plus. This second curve is for 2 H pluses, because we know H2SO4, when it breaks up, will give an H plus, an H plus, and an SO4 2 minus. Okay, so if you had a concentration of 1.5 molar H2SO4, then you would have to take this and multiply by 2. So you would have 3 molar H plus given off because 2 H's are coming from 1 H2SO4. So now let's go through a simple calculation. This one's going to be a 1-to-1, which is more likely what you will see. But I'm preparing you, for college level chemistry classes. So how much 2 molar HCl is needed to be neutralized by 50 milliliters of 1.5 molar LiOH. So LiOH is the base. So this is our MB and our VB. We know the molarity of our acid, but we don't know the volume of our acid. So we've got MAVA is equal to MBVB. We're looking for VA, so we're going to cancel out the MAs by dividing both sides, which will lead us to 1.5 molar times 50 milliliters over 2.0 molar, where we can cancel the M's, and then you just multiply and cross and divide, just like we did with the dilution formula. It's 50 divided by 2. So it looks like to neutralize, we would need 37.5 milliliters. Okay. And it should be easy enough because you don't have to do any transformations here, because you can stay in milliliters for these calculations. So now it's your turn to go ahead and try this example. Pause the video and you can try that.